In the last chapter, we had alpha substitution reactions, where with a base, we made a enolate and then alkylated at the alpha position, right? Let's compare what happens here. With aldehydes, right, pretty much most aldehydes will very favorably react with catalytic base to produce a majority of the combined product. It's called a dimer when we mix two of the same molecules together to make a new molecule. Okay? So aldehydes will react favorably. It is reversible, so there's an equilibrium that happens here, but the aldol product of a small aldehyde like this is favorable energetically. However, if I start with a ketone like this, self-condensation is unfavorable because of steric effects. We have a much larger nucleophile. We have more alkyl groups around the electrophile, right? Everything is more crowded. The reaction has a higher transition state and ends up being slower because of the high transition state. It ends up being higher in energy as well. So ketones themselves are usually not favorably condensed with themselves. We said that a second ago. It requires the aldol reaction only needs catalytic amounts of base. The base does not need to be extremely strong. Okay? The hydroxide ion is sufficient because with an aldehyde we end up with a stable product. Okay? In our last chapter, when we did alpha carbon alkylation, where I had like a ketone and I wanted to alkylate, we needed one full equivalent of our very strong base, LDA. That's important because for every enolate we make, we consume one equivalent of LDA. And remember, we used LDA because it's nice and bulky. It won't add to the carbonyl. All it will do is deprotonate. So we end up with just one H there. Okay. So, and it's two steps. First step is adding LDA to form the enolate. Second step is adding the electrophile to alkylate. So even though they both react by base, the reaction sequence is a little different. Aldehydes will condense on their own with catalytic amounts of base. That's why at the end of last chapter we said that aldehydes cannot be directly alkylated at the alpha position. They'll just condense with each other much faster. Any amount of base with an aldehyde will cause it to condense that way.